Okay, for the participants who are there right now, please put your name in the comment section so that I could recognize you. Again, for the participant who is watching there right now, please write your name in the comment section so that I could recognize you. Again, for the participant who is there right now, you can comment down your name so that I am able to recognize you. Okay, since we are finished now with our introduction, I think we should start now the discussion. As of now, I'm seeing two participants who are there. And for the two participants, the first to comment their name in the comment box will have their prize later on. So if you are there watching and listening to me right now, you can you can always you can write your name there in the comment box. I will wait for you so that you are able to claim your prize later on. Okay, so at this moment, I am going to discuss about series. And our topic to be discussed, or are the learning objectives rather, are how are you going to illustrate series? So you are going to make your own series based on the given equation or the given formula, and also differentiate a series from a sequence. Those are the two objectives that we are going to meet before the end of this session. Okay, so let's start. What is a sequence? A sequence is a list of objects or events which have been arranged in a sequential manner. It is a function whose domain is the set of positive integers or the set 1, 2, 3, and so on. Okay, so a sequence is a list of object of events which have been arranged in a sequential manner. When we say sequential manner, it means that it is sorry, it is in a system, or rather, it is in um, what do you say that? It is in order, okay, from the set of integers, which is can be considered as 1, 2, 3, and so on. Okay, let's continue. What is a series? Okay, a series represents the sum of terms of a sequence. Okay, as you can see, a sequence is just separated by comma, and series represents the sum. So therefore, you will see or you will notice that there are plus or subtraction signs that you can between the two quantities. So if a sequence is finite, we will refer to the sum of the terms of the sequences as the series associated with the sequence. So when we say finite, it means that this can be counted. And when we have that sequence which is infinite, therefore the terms cannot be counted. Okay, so let's continue. We have here the sequence with nth term is usually denoted by a sub n, and the associated series is given by S is equal to a sub 1 plus a sub 2 plus a sub 3 and so on. Okay, so your a sub n is the term, and the sum of the sequence is considered as the associated series. Okay, so for example, determine the first three terms of the sequence and give its associated series. So, as you can see, if you are going to determine the first three terms, you can have 5n minus 2, and all you have to do is substitute the values of n as 1, 2, 3. Okay, so for n sub 1, we can have 5 times n minus 2, which is 5 minus 2 equals 3. Then, for a sub 2, or the second term, we can have 5 times 2 minus 2 equals 8. And so 5 times 2 equals 10, minus 2 equals 8. And for a sub 3, we have 5 times 3, which is 15, minus 2 equals 13. And so the associated series would be a sub 1, which is 3, plus a sub 2, which is 8, and a sub 3, which is 13, should be added. So 3 plus 8 plus 13 is equal to 24. So this will be the associated series given the first three term of the sequence 5n minus 2. Let's continue. Okay, so find the first 6 terms of the sequence and its associated series. So for number 1, we have 2 times n plus 1. Number 2, we have n times n minus 1. And number 3, we have n plus 1 over 2. Take note that all the activities that are discussed here will not be considered as your activity on your math packs, but rather you are going to pass the activities which are not answered here during our live session. So I think you should answer numbers 3 to 5 or numbers 4 to 5 or rather 4 to 6. Okay, so those are the um, activities that I will ask you later on. So we just have to answer this 1, 2, and 3. Okay, so just wait for the whiteboard. I will remove this first and add another one. Okay, so our number 1 is 2 times n plus 1. So that will be our equation, and that will be our formula rather, and we are going to find the first 6 terms of the sequence and its associated series. So for the first term, you have to substitute. For a sub 1, you have to substitute 1 instead of n. So 2 times 1 plus 1, that is equal to 2 times 2, which is 4. For a sub 2, we have 2 times 2 plus 1 equals 2 times 3. That is 6. For a sub 3, we get 2 times 3 plus 1. That is 2 times 4, which is equal to 8. For a sub 4, that is 2 times 4 plus 1. So that is 2 times 5, which is equal to 10. Next is a sub 5, which is 2 times 5 plus 1, which is 2 times 6. That is equal to 12. And for the last one, a sub 6 equals 2 times 6 plus 1 equals 2 times 7, which is 14. So if we are going to find the associated series, we have to add all the values that are listed there from a sub 1 to a sub 6. So our S is equal to 4 plus 6 plus 8 plus 10 plus 12 plus 14. Okay, and that is equal to 10, 20 plus 20, that is 40, and 14, we get 54. This will be the answer for letter S. Okay, for the first student, winner of 50 peso load, nakita ko na ang comment. So, as you can see, we have there Dale Roche. Okay, so Dale, you have to PM me later on with your number so that I can give you your 50 peso load. Okay, congratulations. Dale Roche is the first to sign in and write his name in our comment box. So that would be considered as the attendance of the participants. Okay, so let's go back to our discussion. For the first equation, we have 2 times n plus 1. And so the number of terms which we are going to find are 6 terms. So we have this formula. So 4, 6, 8, 10, 12, and 14. And the associated series will be the sum of all the numbers that we have listed. So 4 plus 6 is 10, plus 8, 18, plus 10, 28, plus 12, 40, and plus 14, we get 54. So the associated series will be equal to 54. Okay, so that's it for number 1. Let's continue to number 2. Okay, I'll find the eraser. Ouch. Eraser. Okay. Number 2 is n, sorry, n times n minus 1. So if we are going to find 6 numbers in the series, it can be, okay, so we have a sub 1, substitute 1 instead of n, so 1 times 1 minus 1. That is equal to 1 times 0, which is 0. Next, for a sub 2, we have 2 times 2 minus 1, which is 2 times 1, that's equal to 2. For a sub 3, we have 3 times 3 minus 1. That is equal to 3 times 2, which is 6. For a sub 4, we get 4 times 4 minus 1, which is 4 times 3. That is equal to 12. For a sub 5, that is 5 times 5 minus 1, which is equal to 5 times 4. That is 20. And for a sub 6, that is 6 times 6 minus 1, which is 6 times 5, which is 30. Okay, so these are the 6 terms of the sequence. If you are going to list that, you can have 0, 2, 6, 12, 20, and 30. Okay, those are the 6 terms. And if we are going to find the associated series, it is 0 plus 2 plus 6 plus 12 plus 20 plus 30. So we have 2 plus 6 is 8 plus 12, that is 20 plus 50. So the associated series will be 70. Okay. Next, let's have our number 3. Number 3 is n plus 1 number 3 is n plus 1 over 2. Okay, so for the first term, all we have to do is substitute again 1. 1 plus 1 over 2, that is 2 over 2, or equal to 1. For a sub 2, we get 2 plus 1 over 2, that is 3 over 2, or 1 and 1 half. It can also be represented as 1.5. Next, for a sub 3, we get 3 plus 1 over 2, which is 4 over 2, equal to 2. For a sub 4, that is 4 plus 1 over 2, which is 5 over 2. That is equal to 2 and 1 half, or 2.5. For the a sub 5, or the fifth term, it can be 5 plus 1 over 2, which is 6 over 2. And that is 3. And for a sub 6, that is 6 plus 1 over 2, which is 7 over 2, or 3 and 1 half. Or it can be 3.5. So, if we are going to find the associated series, all we have to do is add. So 1 plus second term, which is 1.5, plus 2, plus fourth term, 2.5, plus 3, plus 3.5. So those are the 6 terms. Then the answer will be, that's 2.5 plus 2.55 plus 27 plus 310. And so the associated series will be 13.5. So 13.5 came from the sum of all the values in our series. So we have in the sequence rather. So 1 plus 1.5 plus 2 plus 2.5 plus 3 plus 3.5. Okay, thank you, John Ray Milo, for being there. I can see your name in the comment box. Okay, so those are the answers for the exercises 1, 2, 3. Okay, let's continue with the next. Okay, we have here the example 2. Determine the associated series of the sequence. So for the sequence A, we have 1/4 plus 1/2 plus 3/4. All we have to do is add them. So we have 1/4 plus 1/2 plus 3/4. And so the least common denominator is 4. And 1/2 will represent 2 over 4. So if we are going to add 1 plus 2 over 4 plus 3, 1 plus 2 is 3 plus 3, that is 6. 6 over 4. Or if we are going to simplify that, that would be 1 and 1/2. Okay, for letter B, we have 1, 3, 5, 7, 9. So if we are going to add this to find the associated series, we have 1 plus 3, 4 plus 5, 9, plus 7, 16, plus 9, we get 25. Okay, now, determine the associated series of the following sequences. So the first given is 2/3, 5/6, 1, 7/6, and 4/3. Given this, you really have to find the least common denominator. So let's try. Let's try to solve that. We have 2/3. What was that? 5/6 plus 5/6 plus 1 plus 7/6 plus 4/3. So the least common denominator is 6. So we have to put 6 in the denominator. Then all you have to do is find a value which will make the denominator 6. So shortcut. So if we have 3 here, that is times 2 to get 6. So we have times 2 here. We also have to multiply it with 2 for the numerator. So 2 times 2, we get 4. So that's 4. Then since we have already 6 here in our denominator, just copy 5. And for 1, it is understood that 1 has a denominator which is 1. And so to make it 6, to make the denominator 6, we should multiply it by 6. And so we should also multiply the numerator by 6. Then we get 1 times 6, which is 6. For the next value, we get 7 over 6. And the last one, we have 4/3. So if we are going to make this 6, it can be 3 times 2, which is 6. So we better multiply also 2 for our numerator. So 4 times 2 is equal to 8. So this will be the numerators that we are going to add. 4 plus 5 is 9. Plus 6, we get 15. Then plus 7, we get 22. Plus 8, we get 30. That's 30 over 6. And so RS is equal to 5. Okay, I hope that you would double check the answers. Ricelyn, thank you for coming. Okay, so I hope that you would double check the answers if it's correct, because sometimes I tend to mislook it. So I'm also counting on you to check it. So 30 divided by 6, the answer is 5. Okay? So that would be the answer for number 1. Let's continue with the another given. The another given is 1, negative 1, 0, negative 2, and 2. Junimei Katoto, welcome. Okay, so if we are going to add this, to find the associated series, all we have to do is add 1 plus negative 1 plus 0. I don't think that, I think I don't have to write this on the whiteboard because it's easy for us to solve this one. 1 plus negative 1 will become 0. Then negative 2 plus 2 will also become 0. So if we are going to add this, the sum will be 0. Therefore, the associated series for this given sequence is 0. Hello, Christine May Calanza. Good morning. And again, let's find this. Okay. Determine the associated series of the following sequence. The first 10 terms of positive integers. Okay, so the first 10 terms of positive integers, that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So all we have to do is add them. Okay, so I'm going to share the whiteboard again. And we should add the first 10 terms here. So we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, this will be the associated series. So 1 plus 2 is 3, plus 3 is 6, plus 4, that's 10, plus 5, 15, plus 6 is 21, plus 7 is 28, plus 8 is 36, plus 9 is 45, and plus 10, that is 55. So therefore, the associated series, given that condition, the first 10 positive integers is 55. So let's try to check if the answer is correct. 9 and 1 is 10. 10, 8 and 2 is 10. 3 and 7 is 10 also. 4 and 6 is 10. So we have 1, 2, 3, 4, 5 times 10, 50 plus 5, that is 55. Okay, so it's correct. So the associated series given that condition is 55. Okay, let's continue again with the next. Okay, so we have here the different kinds of sequence. So first is the arithmetic sequence. So arithmetic sequence is a sequence in which every term is made by adding a definite number called common difference to the preceding number. It means that there will be a constant common difference that must be added with the number, and the next number will be the sum of the common difference and the preceding number. So if the nth term of the arithmetic sequence is a sub n and the common difference is d, if we are going to find a sub n, our formula will be a sub 1 plus n minus 1 multiplied by d. So take note that your n is the nth term or the number of term, then your d is the common difference. And also, the associated arithmetic series or the sum of all the terms with n terms is given by S sub n equals n times a sub 1 plus a sub n over 2. Or that can be also n times 2a sub 1 plus n minus 1 times the common difference all over 2. Those are the formulas that we should consider in having or solving for the associated arithmetic series, okay, for arithmetic sequence. Next, we have the geometric sequence. Geometric sequence is a sequence in which every term is created by multiplying. Take note that for arithmetic sequence, all we have to do is adding a common difference. But here, we consider the common ratio. Okay, by multiplying a definite number, which is called the common ratio, with the preceding number. So the difference between a geometric sequence and arithmetic sequence is that for arithmetic sequence, we consider the common difference, but for the geometric sequence, we consider the common ratio. Usually, for the arithmetic sequence, we add the common difference, but for the geometric sequence, we multiply the common ratio. And also, if the nth term of a geometric sequence is a sub n and the common ratio is r, then you should consider this formula. A sub n equals a sub 1 multiplied by ratio of n minus a of rather ratio sub n minus 1. And the associated geometric series, or the sum of the terms in geometric sequence, is given by s sub n equals a sub 1 multiplied by 1 minus r raised to n over 1 minus r, or that is also a sub 1 times 1 minus r over 1 minus r, over quantity 1 minus r. These are for values if r is not equal to 1. Okay, so r must not be equal to 1 for the given s sub n here, because it will become 0 later on, or 1 minus 1 will become 0 and it will be undefined if we substitute 1 for the common ratio here. Then, when negative 1 is less than the common ratio, less than 1, the infinite geometric sequence would be a sub 1 until a sub 1 times r raised to n minus 1, etc. has the sum and given, which is a sub 1 over 1 minus r. So take note of this given formula. We have finite geometric sequence, wherein we can identify all the given values, and for the infinite geometric series, we can have this formula. Okay, so take note, when we say finite, it means that the terms can be counted, but for infinite series, the terms cannot be counted. And also, take note of this value. Values from greater than negative 1 to less than 1. Those are the possible values of the common ratio wherein this equation is applicable. Okay? So that equation is applicable, or the formula for the series, which is a sub 1 over 1 minus r, is only applicable if the values should be between negative 1 to positive 1. If we get values which is negative 2, positive 2, and so on, 2, 3, 4, 5, and so on, then negative 2, and so on, we cannot consider this formula, and we will never find the sum of the values because they will be infinite, and there would be greater values that we are not able to solve. So we are only able to solve the infinite geometric series if the values of common ratio ranges from greater than negative 1, or ranges between negative 1 to positive 1. I hope that you understand this this discussion, and later on I will give you some examples. Okay, we also have this harmonic sequence, which is a special type of arithmetic sequence. So it is a series of number is said to be in harmonic sequence if the reciprocals of all the elements of the sequence form an arithmetic sequence. So take note that the one that forms an arithmetic sequence is the denominator. Okay, so if a sub n is an arithmetic sequence, then the sequence with the nth term b sub n equals 1 over a sub n is a harmonic sequence. So it will be easy for us to identify the harmonic sequence because there will be a common difference with the denominator. So with arithmetic sequence, there is only a common difference with all the values, but for harmonic sequence, there will be a common difference only in the denominator. But also take note of the similar fractions because sometimes you can be misled or you can mislook it when you are solving. So take note of the similar fractions, like those 1/2 and 2/4 and 3/6. They are similar fractions. So sometimes they are reduced when given in a sequence. Okay, so sometimes you need to make all the denominators equal. Next, for the Fibonacci sequence, which is also a special sequence, okay, it is a sequence of numbers in which element is obtained by adding two preceding elements, and the sequence starts at with 0 and 1. So the sequence a sub n defined by a sub n equals a sub n minus 1 plus a sub n minus 2 for n greater than or equal to 3, where a sub 1 is equal to a sub 2 equals 1. So its terms are 0, 1. So 0 plus 1, we get 1. 1 plus 1, we get 2. 1 plus 2, we get 3. 2 plus 3, we get 5. 3 plus 5, we get 8. And 5 plus 8, we get 13. So if we are going to continue this sequence, we can have 8 plus 13, we get 21. And 13 plus 21, we have 34. So that will be the values for the Fibonacci sequence. But then, this sequence will is not that applicable in our rather we don't have to solve a lot of numbers here in the Fibonacci sequence because we will find it hard to solve that. But this one is also applicable for the Pascal's triangle that we are going to discuss later on in our subject with pre-calculus, and also for finding the roots of the polynomials. Okay, let's continue. Let's find the common difference for this arithmetic sequence. For number 1, we get 35, 32, 29, and 26. For number 2, we get -3, -23, -43, and -63. Then -34, -64, -94, -124. So if we are going to find the common difference of that, all we have to do is subtract the first term from the second term. So 32 minus 35, we get -3. So the common difference is -3. Meaning 35 plus -3, we get 32. 32 plus -3, we get 29. 29 plus -3, we get 26. And so on. Then, next, for number 2, we get our common difference would be -23 minus -3. So if we have to subtract -23 minus -3, that would be equal to 23 plus 3, which -23 plus 3 rather, which is -20. Meaning the common difference is -20. So we have -3 plus -20, we get -23. -23 plus -20, we get -43. And -43 plus -20, we get negative 63. Hello, Janica Lampa and Chena Marie Fernandez. Welcome. Okay. For number 3, we get negative 34, rather negative 64 minus negative 34. So, if we subtract them, we get the common difference as negative 30. So, negative 30. So, negative 34 plus negative 30, we get negative 64. Then, negative 64 plus negative 30, we get negative 94. And lastly, negative 94 plus negative 30, we get negative 124. Okay, that's how easy we find the common difference for the arithmetic sequence. All we have to do is subtract the value of the number on the left to the number on the right. Okay, let's have this one. Given the formula, find the first 5 terms. We have a sub n equals negative 1 plus 7n. Ay, negative 11 plus 7n. So, it's still the same with what we have done. Let's try to do this. Okay, so we have our a sub n, which is equal to negative 11 plus 7n. So if we are going to find the first 5 terms, we can have our a sub 1, which is negative 11 plus 7 times 1. Seven times 1, which is negative 11 plus 7. So that is negative 4. Next, for a sub 2, that's negative 11 plus 7 times 2, which is negative 11 plus 14, which is positive 3. And a sub 3 is negative 11 plus 7 times 3, that is negative 11 plus 21. That is 10. So again, for a sub 4, if you are going to solve that, we get negative 11 plus 7 times 4, which is negative 11 plus 28. That is 17. And for a sub 5, since we have noticed our common difference is 7, negative 4, 3 minus negative 4, that is 3 plus 4, which is 7. 10 minus 3 is also 7. And 17 minus 10 is also 7. Meaning, our a sub 5 would be 17 plus 7, that is 24. And our a sub 6 would be 24 plus 7, which is 31. Those are the first 5 terms of the arithmetic sequence that is given. Let's continue. Okay, find the first 5 terms of this. We have 65 minus 100n. So if we are going to solve that, all we have to do is substitute 1, 2, 3, 4, 5 in the value of n. Okay, so we have a sub 1 equals 65 minus 100 times 1. So if we are going to solve this, we get negative 35. Next, for a sub 2, we have 65 minus 100 times 2. That is 200. Negative 65 minus 200, so we get negative 135. So as you can see, our common difference is negative 100. So we have to continue to subtract 100 to that. So we get negative 235. For a sub 4, we get negative 335. For a sub 5, we get negative 435, and first five terms, no? Okay, so it's first five terms. So those are the terms. The first five terms are negative 35, negative 135, negative 235, negative 335, and negative 435. Let's continue. Okay. Find the fifth term of the sequence. So this time we are going to find the fifth term of the sequence. And we should take note of this formula. This is the formula in finding the nth term of a sequence. So we have to take note of a sub n equals a sub 1 plus n minus 1 times d, which is our common difference. And given a sub 1 is negative 38 and the common difference is negative 100. So let's try to solve this. Okay, so the general formula is a sub n equals a sub 1 plus n minus 1 multiplied by d. And our given is a sub 1 equals negative 38 and our d is negative 100. So we are going to find the fifth term. So our a sub 5 must be, substitute your a sub 1, negative 38. And since our n is equal to 5, we get 5 minus 1 multiplied by common difference, which is negative 100. So we get negative 38 plus 5 times 1 is, 5 minus 1 rather is 4, then multiplied by negative 100. So that is negative 38 plus negative 400. So since that can also be written as negative 38 minus 400. So our a sub 5, or the fifth term, is equal to negative 438. Okay, that is for the first given. Let's continue with the next. Okay, find the fourth term. Our given is a sub 1 equals 35 and d equals 4. Okay, so find the fourth term. So our a sub 1 equals 35. That is equal to, sorry. What are we finding here? Fourth term. Fourth term. So our a sub 4 is equal to our first term, which is 35 plus 4 minus 1 multiplied by common difference, which is 4. So that is 35 plus 3 times 4. So the answer is equal to 35 plus 12, which is 47. So that will be the fourth term given the a sub 1, which is 35, and the common difference, which is 4. Next, find the eighth term of the sequence. On this case, we are given a sequence and we still need to find the common difference. Take note that our first term is already given as 25. And the common difference will be 21 minus 25. And the answer is negative 4. So the common difference is negative 4. So now we are going to solve that. First term is 25. So we are looking for the eighth term. A sub 8 equals 25, which is the first term, plus 8 minus 1 multiplied by the common difference, which is negative 4. Okay, so that is 25 plus 7 times negative 4. We get 25 minus 28. So our A sub 8 is equal to negative 3. Okay, that will be the eighth term for the sequence. 8 equals, A sub 8 equals negative 3. Okay, so negative 3. Let's try to check. 25, 21, 17, 13, 11. Sixth term is, sorry, 25, 21. Minus 4, minus 4. I think this is not 4 here. We should put 9 here. This series is this sequence rather is wrong. So we have 25, 21, 17, 13, 9 minus 4 is 5. Then that would be the sixth. Minus 4 is again, minus 4 is 1. Then minus 4 is negative 3. So that would be the eighth term. Okay, let's find the third term for this. Take note that our given is A sub 37 equals 249, and our common difference is equal to 8. Our 37th term is given, and so we are going to find A sub 1 in order to find the third term. So let's try to solve that. All we have to do is substitute the values. Okay, so our A sub 37, or the 37th term, is equal to 249. Our common difference is equal to 8. So it means that our 249 is equal to A sub 1 plus, since it is a 37th term, we get 37 minus 1 multiplied by 8. So we can solve that as A sub 1 equals, A sub 1 plus 36 times 8. Okay, that's equal to 249. So 36 times 8, we get 48. 4, I don't have any calculator here. 8 times 3 is 24, 28. We have 288. Okay, A sub 1 plus 288 equals 249. Okay, so if we are going to solve our A sub 1, we should transfer 288 on the left side of our equation. So we get negative 288 plus 249 equals A sub 1. And so if we are going to solve this, 288, negative 288 plus 249, the answer will be 31, 39. So our A sub 1 is equal to negative 39. Okay. And our common difference is 8. So we are looking for the third term. So if we have to find the third term, so we have A sub 3 equals negative 39 plus 3 minus 1 multiplied by 8. So that's negative 39 plus 2 times 8. That's negative 39 plus 16. So negative 39 plus 16 is 23. So our A sub 3 is equal to negative 23. Okay, this will be the answer for our question. Let's continue. Find the 20th term of the sequence. So our given is A sub 40, which is negative 191, and our common difference is equal to negative 30. So let's find the 20th term. So all we have to do is still follow the formula and substitute it. Okay, so we get A sub 40 equals negative 1,191 equals A sub 1 plus 40 minus 1 multiplied by the common difference, which is negative 30. So that is A sub 1 plus 39 multiplied by negative 30. So 39 times negative 30, that is 27. Sorry. 27 carry 2. 3 times 3, 9, 11. 1,170. So our A sub 1 plus negative 1,170. That's equal to negative 1,191. So if you are going to transfer this to the left side, so we have negative 1,191. From negative, it will become positive 1,170 equals A sub 1. So if we are going to add them, the answer will be negative 21. Okay, so that is A sub 1. Okay, now we have our A sub 1. Now we are going to find the 20th term. So our A sub 20 is equal to negative 21 plus 20 minus 1 multiplied by common difference, which is negative 30. So that is negative 21 plus 19 times negative 30. So if we are going to multiply 19 with negative 30, that will be 7 carry 2, 3 times 1, 570. That would be 570, negative 570. So that's negative 21 minus 570. And now our A sub 20 will be negative 591. Okay. Why newer ba na? Welcome. Okay, so our A sub 20 will be negative 591. Okay, let's continue. Mahaba-haba pala to. Okay. Consider this sequence. Okay, now we are now on geometric sequence. Consider this sequence 1, 3, 9, 27, 81, 243, and 729. Find the common ratio and the eighth term. Take note, when we are speaking of common ratio, it means that those are the values that this is the value that we multiply with the preceding number. So, A sub 2 is 3 and A sub 1 is 1. So, to find the common ratio, all we have to do is divide the second term, the first term rather, from the second term. So, A sub 2 over A sub 1. So, we have 3 over 1 and the common ratio is 3. Take note that 3 is our multiplier here. So, 1 times 3, we got 3. Times 3, we got 9. Times 3, we got 27. Times 3, we got 81, and so on. Okay, and to find the eighth term. Okay, so 1, 2, 3, 4, 5, 6, 7. The eighth term will be 729 times 3. So, if we are going to solve that, that's 27, 6, 8, 2,187. So, this will be the value for our eighth term. Okay, next, find the common ratio of the following. Again, before we find the common ratio, all we have to do first is to determine whether it is a geometric sequence or not. Because sometimes there are given that it's not a geometric sequence after all. So, let's try. Okay, this one is all divisible by 6. So, 6 divided by negative 1. Take note that positive divided by negative is a negative value. So the common ratio must be negative 6. 6 divided by negative 1 is negative 6. Therefore, the common ratio of this is negative 6. Take note, negative 1 times negative 6 is positive 6. Then positive 6 times negative 6 is negative 36. Again, negative 36 times negative 6, which is our common ratio, that will again become positive 216, and so on. All you have to do is multiply each with negative 6. Okay? Again, for this one, what do you think will be the common ratio? That is 16 divided by 4, it's 4. 36, sorry, I think this one has missing term. It's 8. Okay, 4, 8, 16. Sorry, 32. I think this given is not considered as geometric sequence. Okay, because you cannot find common ratio between them. 16 divided 4 is 4. 36 divided 16 is not 4. And 64 divided by 36 is really not 4. So I think this has no common ratio. Let's continue with the other one. Okay, negative 2, negative 4, negative 8, negative 16. So, negative 4 divided by negative 2, take note, negative divided by negative is positive. So, our common ratio must be positive. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Now, this can be considered as geometric sequence. And the common ratio is positive 2. Okay, so for this, given the formula, find the first three terms of the sequence. So our formula is a sub n equals 3 raised to n minus 1. And all we have to do is find the first three terms. So let's try to solve that. Okay, so we get a sub n, a sub 1 equals 3 times 1 minus 1. So that is 3 raised to 0. Our a sub 1 is equal to 1. Next, our a sub 2 is equal to 3 times 2 minus 1. So that is 3 raised to 1. Our a sub 2 is equal to 3. And for our a sub 3, we get 3 raised to 2 minus 1. That is, 3 minus 1 rather. So we have 3 squared. Our a sub 3 is equal to 9. Okay, take note that our common ratio is 3. And we have 1 times 3, 3 times 3, 9. And so automatically our a sub 4 must be 27, and so on. So since we are only looking for the first three terms, our answer will be 1, 3, and 9. Okay, next. For a sub n equals negative 4 times 3 raised to n minus 1. So again, our a sub n equals negative 4 times 3 raised to n minus 1. Let's try to solve that. Okay, so our a sub 1 equals negative 4 times 3 times 1 minus 1. So since 3 raised to 0 is equal to 1, so we get negative 4 times 1, which is negative 4. That will be our a sub 1. For our a sub 2, we get negative 4 times 3 raised to 2 minus 1. So that's 3 raised to 1, or 3. Negative 4 times 3 is negative 12. That will be our a sub 2. And our a sub 3 is equal to negative 4 times 3 raised to 3 minus 1, or 3 squared. So that's negative 4 times 9, which is negative 28. Okay, 4 times, negative 36 rather. negative 36. Okay, so our common ratio here is 3 again. So negative 4 times 3, that's negative 12. And negative 12 times 3, that's negative 36. Okay, let's continue with other examples. Find the common ratio. Okay, so we are now given this a sub n equals a sub n minus 1 times 2, and a sub 1 is equal to 2. So how are we going to find the common ratio? Okay, our a sub 1 is 2, and our a sub n is equal to a sub n minus 1 times 2. Now, let's solve that. Okay, so our a sub 1 is 2, so we substitute that. 2 equals, that's your a sub 1 equals a sub n minus 1. Our a sub n minus 1 is a sub 0 times 2. So therefore, our a sub 0 is equal to, okay, so that's a sub 0, 2 times a sub 0, that's 2. Divide both sides by 2. Our a sub 0 is equal to 1. Okay, a sub 0 is equal to 1. And so our a sub 1 is equal to 2. This is just for the sake of solving. So 2 divided by 1, the answer is 2. This will be our common ratio. Okay, this is the second term, and this must be the first term. Okay, so all you have to do is divide the first term to the second term. On this case, our given is first term, so we have to find the number which is behind our first term. So those are the answers. Okay, let's continue. I have visitors here. And again, find the fifth term of this. So the given is a sub 1 equals 0.8, and the common ratio is negative 5. So take note, the common ratio is the multiplier. So we have to multiply this 0.8 times negative 5 times negative 5 times negative 5 until we get the fifth term. So let's try to solve that. 0.8 times common ratio, which is negative 5, raised to n minus 1. So we are looking for how many terms? The fifth term. So since we are looking for the fifth term, that's negative 5 raised to 5 minus 1. So that is 0.8 multiplied by negative 5 raised to 4. So take note that negative number raised to 4 will result to a positive value. So that 0.8 a sub 5. Okay, 0.8 times negative 5 raised to 4 is negative 5 times negative 5, positive 25 times 5, positive 100, negative 125 times 5 is negative 625. Negative 6, positive 625 rather, multiplied by positive 625. Okay, so that will be our answer. 625 times 0.8. Okay, if we multiply that with 8, 40 carry 4, 16, 20 carry 2, 48, 50. Then we should put one decimal place because we have one place here. So we we have to put one decimal place in our answer so that our final answer, a sub 5, is equal to 500. This will be the fifth term. Let's try to check if we are correct. 0.8 times negative zero point 0.5, that is 4. First, I think it's 4. 40. So that's negative 4. 0.8. The next term is negative zero point 0.4. The next term is 520 times 5. That's 100. Negative 100. Yes, it's negative 500. The answer is correct. Let's continue. Find the ninth term of this. Ninth term, so we have a sub 1 equals 4 and r equals 6. Medyo raised to the 8th power ito. Okay, so we have a sub 1 equals 4. A sub 1 multiplied by the common ratio, which is 6 raised to, we are looking for the ninth term, a sub 9, multiplied by 6 raised to 9 minus 1. So that's 4 raised to, I multiplied by 6 raised to 8. Okay, let's find our 6 raised to 8. I think I'll need the calculator right now. And I can see the calculator on my phone. Okay, so 6 raised to 8 is equal to 1 million. Okay, so that's 4 times 1,679,616. Okay, multiplied by 4. Our ninth term would be 6,718,464. Okay, that will be the ninth term for the sequence. Okay, I think it's really easy to use calculator in finding the geometric sequence because we are dealing with large numbers or sometimes fractions. Okay, next, find the sixth term. This will be easy. So sixth term is 6 raised to 5. Okay, because 6 minus 1. So that's 6 raised to 5. I hope that you understand what I am saying. So 6 raised to 5 equals 7,776 times our first term, which is 2. That is 15,552. So that's it. And also, next is find the first term given this one. A sub 4 equals 25 and our common ratio is negative 5. Our multiplier is negative 5. So let's try to solve this. Okay, our a sub 4 equals 25 and our common ratio is negative 5. We are looking for the first term. So it means that we have 25 equals a sub 1 multiplied by the common ratio, which is negative 5, raised to 4 minus 1, which is 3. So that is a sub 1 times negative 5 times 5, 25 times 5. It's negative 125 over 25. So divide both sides with negative 125. Negative 125. So the answer will be a sub 1 will be negative 1/5. Or sorry, negative 1/5 or negative 5 rather. Let's try to check. Negative 1/5. Okay, so negative 1/5. If we try to solve our a sub 2 times 5, times negative 5, we get positive 1. Yeah. This is from negative 1/5 times negative 5. So cancel. Negative times negative, that's positive. Again, multiply it with negative 5. Our a sub 3 will be negative 5. 1 times negative 5 is negative 5. And really, our a sub 4 will be 25. Okay, so our a sub 1 is really negative 1/5. Let's continue. Only tip in solving is you have to understand the formula and also substitute the values. You will never find it hard if you are just substituting the values. Okay, so on this case, we are going to find the first term, but we don't have a common ratio. So our given is a sub 5 equals 768 and our a sub 2 is equal to 12. So all we have to do again is just substitute. Okay, copy our a sub 5 equals 768 and our a sub 2 equals 12. So that's 768 equals a sub 1 multiplied by the common ratio, okay, raised to 4. Okay, common ratio raised to 4. And our a sub 2 is 12 equals a sub 1, your common ratio raised to 1. Okay, so therefore, our 12, or R rather, would be, okay, our R would rather be R raised to 1 is equal to 12 over a sub 1. Since we have R raised to 4, we have a sub 1 over a sub 1 raised to 4. Diba? You have to multiply this 4 times. So a sub 1 raised to 4 is a sub 1. And 12 raised to 4 would be 20,736. Okay, 20,736. So if we can sell this, our 20,736 over a sub 1 raised to 3. This is our a sub 1 raised to 1. Then we can sell that. And this is our a sub 1 raised to 4. Okay, 768. Then, syempre, when we solve this, we have 768 a sub 1 raised to 3 equals 20,736. Now, we are going to divide 768 on both sides. Cancel. A sub 1 cube is divided by 768. We get 27. What number that when we cube becomes 27? So a sub 1 is equal to 3. Okay, 3 times 3 is 9. Times 3, we get 27. So therefore, our a sub 1 is 3. So we should find the cube root of this. And since we have now our a sub 1 and a sub 2, it will be easy for us to find the common ratio. That is, ratio equals a sub 2 over a sub 1, which is 12 over 3. And the answer is 4. So now we have found out that the common ratio is 4. Take note, if we are going to check, 12, a sub 2 is 12, a sub 3 would be times 4, 48, a sub 4 would be 48 times 4, which is 192. And let's check if our a sub 5 is equal to 768. Yes. 192 times 4 is 768. It means that our answer is correct. Okay, let's continue. Ang haba pala. Okay, the sequence versus series. So I have discussed this already before. I hope that you will catch up for those students that were not able to have me during the first part of the discussion. Divine Grace Castor, hello. Okay, so a sequence is a list of numbers separated by commas, while the series is a sum of numbers. So usually when we have that sum, we can also have positive and negative sign for the sum having negative common difference. Okay, so the sequences are the set of elements that follows a pattern, and the series are the sum of elements of the sequence. On the sequence, the order of element is important, but on the series of order of elements is not so important. It depends upon the given. For the finite sequence, we have 1, 2, 3, 4, 5. It means that it only stops with 5. And for infinite sequence, it doesn't stop with 5. It can be continuous until the end. And for the finite series, we have 1, 2, 3, 4, 5. Yes, until 5 only. But for the infinite series, we can have other values. Plus 6, plus 7, plus 8, plus 9, plus 10, and so on. And take note, since our common difference here is 1, for the infinite series, which is arithmetic, we cannot ever find the sum of numbers for the infinite series. Okay? So, identify whether a given is a series or a sequence. Take note that this is separated by comma, and therefore we can say that this is a sequence. And what type of sequence is this? Okay, 7 minus 3 is 4, 11 minus 7. So it has a common difference, therefore it is an arithmetic sequence. Okay, next for number 2. 0, 1, 1, 2, 3. It's obvious that it's Fibonacci sequence. For number 3, 7, 8, 9, 10, 11, take note that there is a common difference in the denominators, which is 1. So there is an arithmetic sequence in the denominators. Therefore, we can say that this one is a harmonic sequence. And for number 4, 6, 12, 18. So 6 times 2, no, 12 minus 6 rather is 6. 18 minus 12 is 6. It has a common difference. Therefore, number 4 is an arithmetic sequence. Yay! We are now finished with our discussion and let's have our quiz. So, I would like to reiterate again that that was Dale Roche, Justin Dale Roche, that is the winner of our first load. So, Justin, you may text me your number later on so that I could give you the load. And there will be additional 2 winners of 50 peso load. So, I'm just waiting for the first to comment of the correct answer in the comment section. Okay? So, the first question is, what is the first 5 terms of the arithmetic sequence if its 17th term is 121 and its common difference is 6? Again, what is the first 5 terms of the arithmetic sequence if its 17th term is 121 and its common difference is 6? I will be waiting for your answers in the comment section so that I can take note who will win for that 50 peso load. Okay, this is our question number 1. Again, I'll be waiting. I'll be waiting for your answers. What is the first 5 terms of the arithmetic sequence if its 17th term is 121 and its common difference is 6? Hello, Cassie Grace Behemino. Cassie Grace. Again, thank you for those people who are watching. So Justin Dale Roche has been a winner of our first 50 peso load. For the second 50 peso load, that will be the one who is the first to answer this question number 1. What is the first 5 terms of the arithmetic sequence? Okay, tip for the answer is that it ranges from between 10 and 50. Okay, so those are the numbers between 10 and 50. What do you think are the numbers? It's not exactly 10 and 50, but those numbers are between 10 and 50. 25, 31, 37, 43, and 49. Again, Dale Roche is the winner for question number 1. He has already 100 peso load that will be given later. Wow! Congratulations! Okay, so si Dale Roche ang naka-answer sa question number 1 correctly. That is 25, 31, 37, 43, and 49. Ricelyn, 1,560 is not the answer. So I think let us discuss how did we find this answer. Okay, so our given is the 17th term, which is 121, equals our a sub 1 plus 17 minus 1, that is 17th term minus 1 times common difference, which is 6. A sub 1 plus 16 multiplied by 6. So a sub 1 plus 16 times 6, we get 96. That's equal to 121. So if we transfer 96 to the left side, we have 121 minus 96 equals a sub 1. And 121 minus 96 is 25. Okay, we now have our a sub 1, 25. Our a sub 2 must be, since the common difference is 6 plus 6, we get 31. Plus 6, we get 37. Plus 6, we get 43. And plus 6, we get 49. So our answer for the first 5 terms will be 25, 31, 37, 43, and 49. Congratulations, Dale Roche. Wow, grabe. Okay, let's continue with the last question. Again, for 50 peso load. What is the difference of the harmonic sequence and the arithmetic sequence? I will wait for the one which has the most sensible answer. The difference between harmonic sequence and arithmetic sequence. Okay, take note that our second session will be later 2 p.m. in the afternoon. I think that would be longer because we have to discuss all the topics this afternoon. Okay, so I'll be waiting for the answer on question number 2. Again, for 50 peso load. Para happy ang New Year. For a happier New Year. Anyone who can answer our question? I hope later on there will be people who will sponsor our loads for the participants. But as of now, SRI will be the sponsor of our loads. Okay, again, I will be waiting for your answer on question number 2. I'll be waiting for your answers. Okay, anyone who can answer what is the difference between the harmonic and arithmetic sequence? Harmonic sequence has a common denominator while the arithmetic sequence has a common factor. John Ray, ano man? A harmonic sequence doesn't have a common denominator but common blank in the denominator. Again, it's not the common denominator but common blank in the denominator. While the arithmetic sequence has common blank. Okay, so you have used the different term. Please correct your term. You can have as many answers as you post as long as there is this first correct answer. Please don't retract your message. It's okay to be wrong. Wala namang perfect, di ba? Kahit sa relationship. Charot. Again, I will be waiting for your answers. John Ray, I think you had that wrong term, but you can correct that. Ubuson ni Ubuson ni karon ni Justin ang 150 nga load for the morning. And later on this afternoon, we will also have this 150 load. So, please participate. Again, question number 2. Why pa man gali isang mga participants from other schools, maybe they are not informed well of this live. So, kamo lang nga classmates ang kontrahanay. Okay, again, what is the difference between the harmonic sequence and arithmetic sequence? Arithmetic sequence has a common difference in the blank. Kulang man gapon. While correct. Sakto has a common difference while harmonic sequence has a common difference in the denominator. Wow! Congratulations, John Ray Lumilo. You are the winner of the 50 peso load. So, again, to sum up, congratulations everyone. You may message me your number so that I can give you your 50 peso load. You can also request if it can be a Go Surf or whatever promo. So again, our winners are John Dale Roche for 100, a total of 100 peso load, 50 plus 50. And John Ray Lumilo for, again, 50 peso load. Congratulations for all the winners. And let's see each other again at 2 in the afternoon because I will be discussing more about sequences. So if I have time, I will have another session on Saturday or on Friday so I could give you more advanced lessons and discussions. And I will look for ninongs and ninangs or someone who can donate us more sponsorship for our prizes. Okay, thank you for being with me on our live this morning and see you later in this afternoon. Okay, congratulations again sa tanan nga winners and thank you for those who have been here since this morning. Dale Roche, John Ray Lumilo, Ricelyn Gallego, Ricelyn Gidman, Junimay Katoto, Christine Marie Calanza, Jenica Lampa, Sheena Marie Fernandez, Winnie Wervana, Divine Grace Castor, and Cassie Grace Behemino. Thank you so much. Okay, congratulations and see you later for our next live. I will send the link and post the link in my timeline. Bye! Pwede na ka mo ka-log out. Thank you so much. Basi may mga special request ka mo for shout-outs? You can type it in the comment box and I will read it. Special greetings for New Year. Okay, John Ray and Dale, you can text me your numbers so I can send you your load. Or basi gusto nyo, or maybe you'd want it to be accumulated until this afternoon. It's also okay with me. And for those who have not been the winner this morning session, please try to participate this afternoon. Who knows? Maybe you can win or you would win our promos.